So this doubt was posted by Kanksha. We have discussed something similar to this in our numbers class. I'll repeat that. I'll discuss from the basic point of view itself, so that you get a clarity into this. So the question is: a natural number n is taken in this range. N is ranging from 120 to 240. When I say from 120 to 240, I'm obviously meaning including both. That is what is mentioned in the question. And the HCF of n and this the number n and 240 is 1. So whenever you have a question like this, HCF is 1. So first thing you should always do is factorize the number, right? So 240 should be factorized, because if HCF of n and this number is 1, so they are co-prime, implying that n should not have any of these prime factors. So n should not have prime factors 2, 3, and 5. So n should not have any of these prime factors. So that is the given constraint. Now we're looking for how many such values of n are possible. So there's a range of n's. Obviously, in this limit, we will be able to figure out. Now, the fastest way to look into this problem, I mean, the idea was developed by Euler, so it's a simple probability idea, if you can understand this. So you have for every 30. So the reason I took 30 is this: the primes that we are focusing on are 2, 3, and 5, and if you multiply 2, 3, 5 simply, you get 30, right? So if you consider 30 consecutive numbers, any 30 consecutive numbers, every second number will be a multiple of 2. So if every second number is a multiple of 2, so if I consider, let's say, 6 numbers, 6 is also a multiple of 2. Now every second number is a multiple of 2. What do I mean by that is, it could be that this and this are multiples of 2. It could very well be something like this and this is a multiple of 2. But if I take even number of values, the reason of a even is it should be a multiple of 2. That many values you should consider. So if I consider any consecutive set of numbers, the consecutive set of numbers being a multiple of 2, in that case every alternative number will be a multiple of 2. Similarly, every third number will be multiple of 3, provided the number of values that we consider is I mean, a multiple of 3 itself. So in this case, 30 that I've considered is a multiple of 3, right? So every second number is a multiple of 2, every third number is a multiple of 3, every fifth number is a multiple of 5. So what I can say is directly that the probability of finding the multiples of 2, finding the multiples of 3, and finding the multiples of 5 will be 1 out of every 2 number, 1 out of every 3 number, 1 out of every 5 numbers. So simple enough, right? So if I have the probability of finding a multiple of 2 being half, one third, multiple of 2 is one third, half, multiple of 3 is one third, and multiple of 5 is one fifth, then the corresponding complementary probability, so probability of not finding a multiple of 2 is 1 minus half. The probability of not having a multiple of 3 is 1 minus one third, and probability of that not being a multiple of 5 should be 1 minus one fifth. I hope this is very simple enough. So what should be the probability that we don't have I mean, we have a number which is not a multiple of 2, 3, and 5. So if that is true, so these are independent of each other, right? Because a number not being a multiple of 2 has nothing to do with not being a multiple of 3, because 2 and 3 are different prime numbers. So if they are independent events, we can straight away multiply these probabilities. So the probability of not finding a multiple of 2, 3, as well as 5 should be 1 minus half, 1 minus one third, and 1 minus one fifth. So you can evaluate at this particular point itself. What you'll get is, I mean, this entire thing will evaluate to something like 8 by 30. So out of every 30 numbers, you should have 8 numbers. This probability is indicating that, right? Out of every 30 numbers, I'm not, I could reduce this further, but I'm not doing that, because we are looking for 30 consecutive numbers. This will be a simple way to look at it. So if the probability is 8 by 30, so we can claim that for every 30 consecutive numbers, there will be 8 numbers which satisfies this condition, that is not a multiple of 2, 3, and 5. So just the order is changed. Ignore that. So 8 numbers, not multiples of 2, not multiples of 2, not multiples of 3, and not multiples of 5. So if for every 30 consecutive we have 8 numbers, now consider the range here. So we have 120 to 240, right? In total, in this set, we will have how many numbers? So 120 to 240. If we think about this, so we'll have a total of 121 numbers, right? But we can ignore one of them, because any which way we can see that 120 is multiple of 2, 3, 5, and all. So we can ignore one of them. So if I ignore one of these values, then I get 120 numbers in total. So something like 120 from 121 to 240. So what I'll consider is, instead of 120 to 240, I'll consider 121 to 240, because 120 is anyhow not satisfying the condition. So if I consider from 121 to 240, we have a total of 120 numbers. So for 30 numbers, we have 8 numbers, not multiples of 3, 2, and 5. So for 120 numbers, we should have a total of 8 into 4, because there are 4 groups of 30, 32 numbers, which satisfies the condition. So this is the answer for this question.